The types of questions that can be answered by the application of thermodynamics all involve a change of state. We start with the system in some initial, well-defined initial state. Some process occurs which takes the system to a well-defined final state. The questions we are asking have to do with the change in energy, the change in entropy, or the change in some other property of the system when this process occurs. But what do we mean by a well-defined state of the system? The state of the system is said to be well-defined when the system is in equilibrium. There are several types of equilibrium that we consider. Thermal equilibrium implies that the temperature is consistent throughout the system. And mechanical equilibrium indicates that there is no imbalance in forces, or the pressure is constant throughout. Finally, we can have, or we need to have, chemical equilibrium. A system is in chemical equilibrium when the chemical potential of each component in the system is constant throughout. The chemical potential of each component in the system is a function of the number of moles of each component in the system. Thus, for an equilibrium state of the system, the temperature, the pressure, and the number of moles of each component in the system are well defined and can be specified for an equilibrium state. These properties of the system are called state variables because they define the state of the system. There's one other state variable that you might be familiar with, and that is the volume of the system. Typically, I do not need to specify the volume because the volume is a function of the temperature, the pressure, and the number of moles through the equation of state for the system. One well-known equation of state, which you've already encountered in your studies, is the ideal gas equation of state, which describes how the volume is dependent on the number of moles, the temperature, and the pressure of an ideal gas.